To show we are asked to estimate and calculate the solutions. So first question, 4/5 divided by 3/10. So when we're dealing with proper fractions, we need to, and we're estimating, we need to determine if it's closer to the number 0, to the number 1, or 1/2. Those are going to be your benchmarks when you're estimating with fractions. So 4/5 is going to be closest to 1. 3/10 is going to be closest to 1/2. So I'm going to say that as an estimate, this is close to 1 divided by 1/2. Well, we can rewrite this as 1 over 1. And I'm going to use the reciprocal technique. So I'm going to turn division into multiplication, and then I'm going to take the reciprocal of this, which becomes 2 over 1. And then 1 over 1 times 2 over 1 becomes 2 over 1, which is just 2. So my estimate is that our solution is going to be 2. Now, let's do the real deal. 4/5 divided by 3/10. Well, there's two methods. We can use the common denominator technique, and I'll do that first. 5 and 10, so I'm going to go to tenths. 3 is already over 10, so we'll leave that one. 5 times 2 is 10. So if I multiply the bottom by 2, I have to multiply the top by 2. So 4 times 2 is 8. Now I have a common denominator, so I can drop my denominators. And this becomes 8 divided by 3, or 8/3. Now it's improper to leave an answer as an improper fraction. So we're going to convert that to a mixed number. 3 goes into 8 2 times. That gives you 6. So you've got a remainder of 2. And then your denominator stays a 3. So 2 and 2/3. That's one method. The other method is using your reciprocal. So you write your first fraction as it was, change to multiply, and then take the reciprocal of the second fraction. So then this becomes 4 times 10 over 5 times 3, which is 40 over 15. Now you can either reduce this now or convert it to a mixed number and then reduce further at that point. I'm going to reduce it now. So 40 and 15 have a common factor of 5, so I'm going to divide top and bottom by 5. When I do that, 40 divided by 5 is 8, 15 divided by 5 is 3. So again, it's an improper fraction. 3 goes into 8 2 times with 2 remainder. So 2 and 2/3. So both methods came up with the same answer. 2 and 2/3 is kind of close to 2, so our estimate of 2 was reasonable. Probably that means, since we've calculated this number twice, that that is the correct answer. So that's A. Same strategies involved here for part B. 2/9. We're going to estimate first. Half of 9 is 4.5. 2 is actually closer to 0 than it is to 4.5, so I'm going to say that that is close to 0. 5/6, half of 6 is 3. 5 is closer to 6 than it is 3, so that is close to 1. Now 0 divided by 1, well, that's going to give us an estimate of 0. So 2 over 9 divided by 5 over 6. Let's do the actual calculations. I'll use the common denominator technique first. And in this case, with the numbers 9 and 6, I'm going to go to 18. So I'm going to say something over 18 divided by something over 18. 9 times 2 will give you 18. So 2 times 2 will give you 4. 6 times 3 to go to 18. So 5 times 3 is 15. Common denominator, so we can drop them, and we go straight to 4 over 15. That is my answer in lowest terms. So, once again, let's have a look at using the reciprocal method. First fraction stays the same. Turn it into multiplication, flip the second fraction over. That means that we've got 2 times 6 over 9 times 5, which is 12 over 45. There is a common factor here of 3. So I divide top and bottom by 3. And 12 divided by 3 is 4. 45 divided by 3 is 15. Once again, we've got similar answers, or identical answers actually. 4/15, that is kind of close to 0. Half of 15 is 7.5, so it's slightly closer to half than it is to anything else, but 0 is reasonable. So that's part B. Part C, where you've been given mixed numbers. Dividing with mixed numbers is not real helpful, so we're going to want to convert those to improper fractions, but first let's do some estimating. 3 1/6, that's going to round to a 3, so I'm going to leave it at that. And 1 2/3, that would round up to a 2. So I'm saying that as an estimate, we're doing 3 divided by 2, which you can rewrite this way, which 2 goes into 3 once with 1 remainder. So we're estimating that it's about 2.5. So let's do our calculations. First up, I'm going to convert these to improper fractions. Both methods are going to require that. So 6 times 3 is 18. 18 plus 1 is 19. So we're looking at 19 over 6. And then our second one, 3 times 1 is 3. 3 plus 2 is 5, so this becomes 5/3. So this becomes our new question that we're going to work with for both methods. First up, we're going to use the common denominator method. So I'm going to go over 6's. We've got a 6 and a 3, so I'm just going to double top and bottom here to go to 6 in the bottom. So 3 times 2 is 6, 5 times 2 is 10. So common denominator, so we can just drop it. This becomes 19 over 10. And if we look at that, 10 goes into 19 once with 9 remainder. So my answer is 1 9/10. Let's look at the reciprocal method. Again, same fraction to start with, 19 over 6 divided by 5 over 3. First fraction doesn't change, but we go to multiplication instead of division and we flip this one over, so it becomes 3 over 5. "19 times 3, well, that gives you 57. 6 times 5 is 30. Now, these are big numbers, and you might not recognize a good common factor to reduce by. So in this instance, I might actually convert to a mixed number first. So 30 goes into 57 once and leaves you with 27 left. So we're looking at 1 27/30. Now, these are smaller numbers, and I can see that the factor of 3 can come out of this. So if you divide 27 by 3 and you divide 30 by 3, then you're going to end up with 1 whole. 27 divided by 3 is 9. 30 divided by 3 is 10. 1 9/10. So same answer, a little bit more work involved in this technique. But now let's compare these. 1 9/10, that's almost 2. Our estimate was 1.5. That's not that far off. So it was a reasonable estimate, and the answers, both techniques came up with the same solution, so chances are it's right. So that is the solution to part C. Next up, some more notes.